All right, now that we've defined stress for ourselves, let's go ahead and look at a mathematical example using this formula. So let's go ahead and solve for another truss. You remember trusses? Let's draw ourselves a quick little truss bridge. And let's I should draw that a little bit better. But let's say right down here at the middle, we got 1,200 pounds of force going down. Go ahead and calculate member AD for me. You have 20 minutes to go. All right, I'm kidding. Let's go ahead and pretend like we calculated out this entire bridge. And let's say we got exactly 800 pounds of compression going out for this. Let's go ahead and call that compression. That should be an 8. 800 pounds of compression. And just in case you cannot read this very small picture here, and this should be more like this should be my triangle, but whatever. Hopefully you get the idea. Let's say we did all of this and we say member AD equals 800 pounds of compression force. Compression. All right. So we know it's force. All we need is the area. And for member AD, the area, we use rectangles, you might recall when we calculated it. I should say member AD area equals, the formula for area for anything is usually the base times its height. And we're going to use the members that we actually used when we built our bridges in this class. Which were these? Does anybody know the length of this? It was
1x2.
It was a 1x2. Very good. So these were all 1x2 boards that we used. It doesn't matter how many times you cut it, it's still an area of 1x2. Which for some reason, probably a very good reason, but not one we'll discuss in this class, 1x2s are not really 1 inches by 2 inches. If you measure it, it's about 3/4 of an inch by 1.5 inches. So it's really 0.75 inches multiplied by 1.5 inches, which I'll save you the math. You get about 1.125 inches squared for your area. So if we wanted to solve for stress now, what we would do is we'd say, well, let's do that in blue instead of green. We'd say stress equals force over area. And we know both those numbers, right? We know force is 800 pounds. And we know area is 1.125 inches squared. And again, I'll save you the math. We'll round to the nearest hundred. We'll say stress equals 711 or 711. You can bet that I picked those numbers for a reason. 711 pounds per inches squared. Does anybody know another way to write pounds per inches squared? PSI. Very good. So another way to write this is stress equals 711 PSI. Sad. Any questions on this? There's one thing I do want to point out for you. This should be obvious. This should be a dull moment. But for stress, as force goes up, what happens to your stress? It goes up. The stress on the member, as the force goes up, the stress also goes up. As the area goes up, so if you increase the size of what you're applying the force to, what happens to your stress? Your stress decreases. So we can think about that logically. Again, if we make it bigger, there'd be less stress on it. But another way to look at it is areas on the bottom of our fraction. A bigger number on the bottom means overall smaller number, so our stress goes down.